that be? Who is the anonymous caller?
That's probably me. That's probably me. I got my audio. I dialed in with my phone for audio.
Okay. Sounds good. Thanks, James. I just I appreciate that. I just do it. Blackboard gives me a list of students that I use to keep attendance, so I want to make sure I get everyone captured here. Thanks.
I don't know if mine is coming up anonymous, but I'm driving right now. This is Ayana.
Hey, Ayana. Actually, I think that's you. So, thanks for checking, and I'll make sure that I mark you present rather than absent. So. Okay, we were talking about rigid board insulation. A couple major types here, right? This extruded polystyrene is what we are likely to see in our exterior sheathing or our below grade wall insulation or under slab insulation. Has an R value of roughly 5 per inch. Says high compressive strength and water resistance. The polyisocyanurate we're likely to see on commercial roof insulation, right? If we have a commercial building that has a flat roof, typically that insulation is installed on top of the roof deck and below the roofing. Polyisocyanurate would typically be what would be used there. It has a little bit higher R value, you see 6 or 6.5 per inch. Right? So thermal bridging, right? We're now using rigid foam to address that thermal bridging. We saw that in the picture a few minutes ago. Ayana, you'll have to, I'll post the slides. You can go back and look at the slides or watch the recording. Right? Code requirements, cover your foam inside and out. So a lot of these foam insulations are flammable. So if you're using them inside, they typically have to be covered with some at least half inch of gypsum wallboard, or to provide fire resistance. So again, the code will spell those things. Oh, what's going on? Some more data. I'm going to move along here. Right, here's an example. Another insulation type would be loose fill or blown in. So in this case, you see the picture of a technician with a hose that's in essence blowing that insulation into an open attic. So in this case, there's likely to be a truck parked out on the street and a person inside that truck loading bags of insulation into a machine. And on the other end of the hose is someone who's blowing that insulation into an attic. So that's a typical application for blown in or loose fill insulation. Right, here's another application for loose fill insulation. This is our house. We insulated the walls in our house, I don't know, 5 or 6 years ago now. So you see in this case we have a older bungalow with wood frame walls and wood siding. So the people doing the insulation peeled off a strip of siding and they drilled holes from the outside and they filled those wall cavities with insulation. Right, here's again a person who's got the hose stuck in the hole on the outside of our house blowing in insulation. Some places that they couldn't get from the outside, they blew in from the inside. So again, this is the same crew, drilled holes inside the house and blew in some insulation from the inside. Again, from my perspective, these are all things that we need to figure out and get better at. We have we have lots and lots of houses that need to have their levels of insulation improved, got better, more insulation. right? If we want to address our climate change problem, we got to figure out how to insulate a whole city full of houses, right? Drilling holes. I had to go, in this case, once this gentleman patched the holes, and I had to go back and repaint, patch and paint these holes in my living room wall. Looks like you're back again, Ayana. Right, we also have spray foam insulation or foamed in place insulation. Some applications here might be open walls, underside of floors, areas that are irregularly shaped or hard to reach. The advantage of a spray foam or foamed in place is that it also provides an air leakage barrier as well as the insulation. So here's some pictures. Boom, there we go. Again, the person who's blowing this insulation, right, typically has some protective gear on. Here's a good example of where blown or foamed in place insulation would make sense, right? This is an attic with all sorts of irregularly shaped stud spaces. It would be difficult to get blanket or bad insulation to stick or to stay in this particular case. So, foam insulation is a good application here. Right, here's again, back in our house, we had these guys come in and do the insulation in part of our basement. So again, this is a basement workroom where this person here is blowing foamed in place insulation in kind of these irregularly shaped stud walls in our basement. Right, here's the finished product. We also had some blow some insulation in the space that's underneath our pantry. Again, I could never get bats to stay there. They would always fall down. The foamed in place insulation took care of that problem. Again, we have trade-offs. Again, all this foamed in place insulation, if it's in a habitable space, has to be covered with drywall. And some of these foams and these materials have some issues in terms of the chemicals, but so they need to be applied thoughtfully. Right, we also, when we're looking to make our buildings more efficient, to improve the quality of our building envelopes, we also have to think about air leakage or infiltration. We all have a sense of what that means. If we live in Chicago, right, probably all of us have lived in houses or apartments where on a bitterly cold day when the wind is blowing, we just can't keep ourselves warm, right? No matter how high we turn up the thermostat. Often that's due to air leakage, right? We have air leakage is essentially, or infiltration is essentially uncontrolled air leakage. So our goal here, by fixing all these different cracks and gaps in our homes, is to move from infiltration, which is uncontrolled leakage, to ventilation, which would be more controlled air movement. Right? How do we do that? Again, a tool that's often used in addressing some of these air leakage problems is what's called a blower door. You see it, this picture on the left, and essentially it's a fan that's installed in an outside door of the house that's trying to essentially simulate what it's like if the wind is really blowing, increase the temperature, increase the pressure differential between the inside and the outside, and allows the technicians to find those sources of air leakage. So that's one tool that's used to tighten up or reduce air infiltration. This is a picture of that thermographic camera, right? That would be another tool that technicians or installation contractors could use to visualize where some of these sources of air leakage are. Right, here's our blower door testing again with the blower door and the thermography. We get a visual picture of where some of that air leakage is, and then we can go about fixing it. Okay, I realized that I was standing up stretching my legs on break, and I forgot to load up my next presentation, so give me a minute to do that, and I'll be right back. Sorry about that.